Got a new presentation for you today. My name's Chris Potter. Today is June 17th, 2017. The Nemesis theory refers to the idea that the sun is part of a binary system, and that other star in the system is a red dwarf star called Nemesis. The two stars supposedly approach each other every 26,000 years. In addition, a planet called Planet X orbits both stars and comes close to the Earth once every 3,600 years. Every time either Planet X or Nemesis comes into the solar system, they go through a cloud called the Oort cloud with trillions of rocky objects. This causes some of those Oort cloud objects' orbits to be disturbed so that some of them come into the solar system in the direction of the sun and become comets. Figure 1. Two stars moving around one common center called the center of mass of what is called a binary star system. About 80% of all star systems are binary according to NASA. Since approximately 80% of all star systems are binary star systems, it is very possible that the sun is part of such a system. However, it is difficult to explain why such a star has not been found yet, unless it is off course and very faint. It is perhaps for that reason that it has been hypothesized that if the sun's twin does exist, it is probably a red dwarf star. Red dwarf stars are main sequence stars, but they are also much smaller and dimmer than stars like the sun, as illustrated in Figure 2 below. Figure 2 shows a red dwarf smaller, cooler, and fainter than a main sequence star like the sun. Red dwarf stars vary in size between 0.075 and 0.5 times the mass of the sun, and their surface temperature is usually 4,000 Kelvin or lower, whilst the sun's surface temperature is a much hotter 5,700 Kelvin. This lower temperature means that the star will emit a light that can be described as being between yellowish-orange to being orangey red, whilst the light emitted by our sun can be described as white. Now, the Nemesis theory is intertwined with the idea that there is a planet that orbits the two stars called Planet X, and that this planet has a period of 3,600 years. However, the problem is that if the planet orbits the two stars, it would have to have an orbital radius that is larger than that of the orbital radius of the least massive star with respect to the other. And then according to Kepler's law, its orbital period would also have to be larger than that. Kepler's law can be easily illustrated when we look at the orbits and periods of the planets in the solar system as shown in Figure 3 below. The further a planet is from the sun, the longer is its orbital period, which is the length of time it takes for it to complete one rotation around the sun. So Figure 3 is showing us a solar system scope view of the planets Mercury, Venus, Earth, Mars, Jupiter, and Saturn with respect to orbital periods in yellow. The further out a planet is from the sun, the longer its orbital period will be. Now Figure 4 Now Figure 4 below, okay, illustrates where Planet X's orbit would be in relation to those two stars, okay? It would have to orbit outside the orbit of the smaller star around the sun, and that means that its orbital period would have to be higher than 26,000 years, and therefore it would be impossible for it to be 3,600 years. Interesting. Figure 4. Planet X orbits outside Nemesis' orbit with respect to the sun and will therefore have to have an orbital period greater than that of Nemesis or greater than 26,000 years. A number of comets come into the solar system periodically. Those with an orbital period of less than 200 years are thought to come from the Kuiper belt, which is a disk on the ecliptic plane beyond the orbit of Neptune between 30 and 50 astronomical units away. The Kuiper belt is similar to the asteroid belt. Many comets, though, have more open orbits, which translates into longer orbital periods and therefore seem to come from beyond the Kuiper belt. So, It has been theorized that the solar system is surrounded by a spherical cloud of icy and rocky objects called the Oort cloud, and that this cloud is where comets with orbital periods greater than 200 years come from. That seems to be kind of a shoddy theory on the surface, don't you think? Figure 5 illustrates the Oort cloud and shows the relative position of the solar system, including the Kuiper belt with respect to it. The Oort cloud is thought to be about 50,000 astronomical units or 1 light year away from the sun. The Oort cloud is thought to be about 50,000 astronomical units across, probably. And she probably mentioned that 1 astronomical unit. Well, okay, so that would be 1 light year away from the sun. Okay, now I understand. All right, never mind. Figure 5 on the left, a view of what the Oort cloud is thought to look like from the outside. On the right, a view inside the Oort cloud showing the solar system and the Kuiper belt. The Oort cloud provides an explanation for the number of long-period comets that are seen coming towards the sun periodically. It is thought that their orbits are disturbed by a passing star. Then, since Nemesis is supposed to have an orbit, Nemesis's passage through the Oort cloud would disturb the objects in it and cause many to dive towards the sun. Thus, large numbers of comets would come into our inner solar system and place Earth in danger of impact with one of these objects. A large comet impact with Earth could have cataclysmic consequences. Figure 6, a comet with its long characteristic tail that flies towards the sun. But the problem with the Oort cloud theory is that there's no actual evidence for its existence. Yeah, that just sounded like a bogus theory to me, but what do I know? As Carl Sagan stated in reference point 1. The Oort cloud is thought to have formed as a result of planetary formation with material that was left after the planets formed being pushed towards the sun. Studies done on this did not, however, consider that the objects that would eventually become comets or comet nuclei would be undergoing collisions. Without considering collisions, the Oort cloud ends up with a mass 40 times that of Earth, but when collisions are taken into account, it ends up with a mass of only 1 Earth mass, and even with some refining, the model will only give up to 3.5 Earth masses, which is not sufficient to account for the large number of long-period comets seen in the solar system. Point 2. Figure 7. Comet's coma is produced due to ion exchange with the solar wind. Comets also have jet-like plasma discharges between the comet nucleus and the cloud of material that surrounds it, and are thus electrical in nature. Now, comet tails are not just dust tails. Comets have a dust tail and a plasma tail, which is produced through ion exchange with the solar wind. Comets then get an induced magnetosphere, which is called the coma. They also have jet plasma discharges between the nucleus of the comet and the diffuse atmosphere that surrounds it. This shows us that comets are electrical in nature and that they most probably interact with the solar wind in this way because they have a different electrical potential to all of the other objects in our solar system. So this means that they must come from outside the solar system, and that when they come in, they start equalizing their electrical potential with that of our sun and the solar system, leading to those effects. So figure 8, the sun travels through the galaxy at a supposed speed of 230 kilometers per second, or 514,000 miles per hour. Yeah. The evidence that there are now brown dwarf stars around our sun is overwhelming. These objects are not natural to the solar system, but they seem to have come into it during the last 100 years. Brown dwarf stars behave similarly to comets, and that even though they are dark when they come in, eventually they are able to have plasma discharges from the core of the star to ionized gas surrounding it. So the thing lights up once it comes in. So you can see it. Hello. Figure 9. Robert S. Harrington was possibly the first astronomer to see that brown dwarf stars were coming in towards the sun. These objects, which we can think of as nemesis objects, was the astronomer Robert S. Harrington. He probably observed one of these brown dwarf stars, or possibly a small system coming in towards the sun back in the friggin' 80s. But it is possible that some more had already come in, and it is clear that a lot more have come in since then. These objects seem to be surrounded by large amounts of ionized gas and debris, and some of that debris may increase the number of asteroids, planets, and comets in our solar system. But what this actually shows is that the galaxy is not just a lot of empty space. The sun is traveling at a supposed 230 kilometers per second, or 514,000 miles per hour, through the galaxy, and it is very likely that it will encounter objects that it has never encountered before. The small, lonely objects that enter the solar system become comets. Old stars become rejuvenated brown dwarf stars as they progress, for having plasma discharges from core to cloud of ionized gas to being able to have fusion reactions on their surfaces and emit light, and even have a stellar wind in a similar fashion to a main sequence star. They turn back on when they come close to the sun. Also, since 90% of stars end up as white dwarfs, the brown dwarf stars are the next step in the aging process of stars. It is likely that our galaxy is absolutely friggin' filled with large numbers of brown dwarf stars which are not visible to the naked eye, since these objects do not emit much visible light and often only emit infrared radiation. In addition, it seems, well, that brown dwarf stars are able to cluster, as the ones now in the solar system have done so, which are sometimes seen very close to each other and go right into the sun's friggin' corona. This suggests that stars are attracted to each other, like friggin' magnets, as if the strong force which keeps protons and neutrons together in the nucleus of an atom is acting on an astronomical scale. It's like protons and electrons around a nucleus, and an atom is like a mini solar system, right? That has the same force. That's what she's compared it to. That force that keeps it together. Figure 10, since 90% of stars become white dwarfs, and the next evolutionary step for white dwarfs is to become brown dwarf stars. The galaxy must be friggin' teeming with extremely well populated as well with the objects. Teeming with the objects, extremely well populated with the objects. You understand what I'm saying. In conclusion, we now have several brown dwarf stars in the solar system, and each of them can be thought of as a nemesis. So we actually have many nemesis stars in the solar system. These stars, though, do not come in and leave as the original nemesis was expected to. These suckers want to stay around and drain the sun. These brown dwarf stars seem to want to remain and drain energy from the sun, and therefore their long-term effects on the sun and the solar system may be very much long-lasting or even impermanent, and thus a lot more dangerous in the end. For reference point 1, Carl Sagan and Druyan, Comments, Random House, New York, page 201. Is the reference she was referring to. And then for reference point 2, Stern, Essay, and Wiseman, PR, Rapid Collisional Evolution of Comets During the Formation of the Oort Cloud, and this is from Nature magazine. It looks like pages 589 through 591, and it looks like it's Nature number 409 from 2001. Thanks for watching and subscribing. Have a wonderful day.